Hello everyone! Today is December 28 and it's time to open a new problem from LeetCode for our Coding Advent Calendar. Today's problem is about data structure called Heap or PriorityQueue. Let's take a look. Here is a problem. Remove stones to minimize the total. You're giving a zero-indexed integer array piles, where piles I represents the number of stones in the pile I, and we have an integer k. You should apply the following operation exactly k times. Choose any piles I and remove half of stones from it, and we need to round it to the bottom. Notice you can apply these operations on the same pile more than once. Return the minimum possible total number of stones remaining after applying the k operations. Floor x is the greatest integer that is smaller than or equal to x, so we need to round it down. Here is an example. 5, 4, 9, and we need to do two operations. So we apply operation on pile 2, which is 9, and it will be 5, 4, 5. And then we apply operation to pile 0, and we get 3, 4, 5, and the total is 12. And the same. Okay, how we're going to do this? So the difficulty here is that we can sort. Well, eventually we need to pick the pile with the maximum number of stones, right? So we can sort our array and pick piles from the greatest number of stones and so on to the lowest. The problem is that we modify these piles. So once we take stones from it, we need to put it into appropriate place in our array. So that's also operation which we need to take care of. But what can we do? We can use a special data structure called PriorityQueue or back. What this data structure allows us to do? Oh, not back, heap, right? Heap. What it allows us to do, it stores data in a sorted order, and it allows us to insert and take items in a logarithmic time. In order to fill this data structure, we need to take n log n operations, which is the same complexity as sorting, right? Then we take the greatest pile from it in a logarithmic time, modify it, and insert it back into our priority queue, which is also log n time. Okay, let's do this. So first, how are we going to take the result? In the end, once we're done with all k operations, we need to go through all items that are modified already and count number of stones. Instead, we will do it a little bit different. We will count the number of stones in the beginning, and we will keep control over how many stones we take from piles, and we will control this total number. Okay, here is our total, and priority queues are available in standard library for .NET, starting from .NET 6, I guess, or .NET 5. And now we need to specify that we need descending order. So the beginning of our heap will tell us the item with the greatest number of stones. Now we need to put all stones in a heap. Here, first item is the item itself. The second one is its priority. Since we are working with integers, so they are their own priority. And we need to do k operations, right? What we are going to do? We take the greatest pile and we calculate the amount of stones to be removed. We reduce this number from total. We calculate the value to update, right? So we remove the number remove from the pile, and we need to put this updated value back in our heap. And we do this. That's it. Done. The time complexity of our solution is big O of n plus k multiplied by logarithm n. N log n is the time of our insertion part, when we insert our data in priority queue in the very beginning. K multiplied by n log n is the part which is for the k operations with the queue. So the time complexity is, as I said, n plus k multiplied by log n. The space consumption is big O of n, because we only need to store additional data structure called PriorityQueue, which is dependent on the length of our input array. PriorityQueue is a powerful data structure which can help you in many different scenarios. You just need to remember what that data structure is about and what it allows you to do. See you tomorrow.